There is one factor that it's good you should mention that. This is a common problem with fast-moving bodies. A very fast-moving body in Corona, and this is really not a Corona thing, this is a Box 2D issue, is a very fast-moving body will do what's called tunneling. Even if it's supposed to hit another body, it may pass through the body with no detected collision and no response. And the reason it does that is because you can imagine the physics engine calculating positions over time. And it's only allowed to do so many calculations per physics body per frame. And so what it does is it estimates the position of an object. It says I can do 2 passes on this. I can do 2 calculations. In this period of time, it's at x100, y100, and then it's moving at some super high rate, and then suddenly it's at x10,000, y10,000, and there was a body at x101, y101. Well, darn it, because it wasn't at either of those points in our 2 attempts to calculate it, it's considered not to have hit the object. Am I being clear? So let me reiterate. As the physics engine is running, every frame, every cycle, for every body, it does a series of calculations on moving bodies and says this body is at point A, point B, point C, however many times it gets to calculate for each object. And then for every point A, B, C that it calculates for every moving body, it does a collision check to see if any other moving body that it's allowed to collide with is in that same space. It does an overlap test or however it achieves the collision check. So you can imagine if an object is moving very fast, that the distance between these discrete checks, A, B, C, could be very large. So if another object is somewhere between A and B, and it's so A and B are so far apart because the moving object is moving very fast, then the engine has no hope whatsoever of detecting a collision. So how do we solve this problem? Long, elaborate build-up here. There's a couple of ways we can solve this, and I will tell you one of them today, and if we wish, we can dig into another one in the future, but it's a little bit too deep for a 10-minute discussion, which is what we have left. Basically what we do is we set a parameter on our physics body, calling this isBullet. It's a sort of like a shorthand notation to do this in one of 2 places, I believe. We can do that here, or if we wanted to, we could put it in the body definition. Type. See, this is what happens when I try to type on the show. Can't type. Let me show you what I'm doing here. What we're trying to do is we're trying to tell the physics engine, you need to pay more attention to this particular body because it's not only moving, but it's moving fast, and we don't want it to tunnel. We don't want it to pass through an object it's supposed to be colliding with and not have a collision. So you can't entirely fix this problem. A super fast body is always going to tunnel. But you can improve your odds of getting a collision by doing one of 2 things. And the first thing we can do is we can set the isBullet field either in the body definition, or later after we've applied the body we can set it as a field called isBullet. Set it to true, and what that does is it automatically cranks up the number of iterations that element gets. So for example, we've got 1, 2, 3, 4, 5, 6 physics bodies on the screen right now. And let's just pretend that at the moment that I paused this one here was marked, the arrow was marked as isBullet. So by default, I believe every physics body gets 2 or 3 iterations, and this could be wrong, but let's just assume that every physics body gets 3 iterations per frame. So for this body, it's moving. The engine says, okay, I started off in position A, I'm going to iterate. Okay, I got a position B, I got a position C, and those are the 3 places where this body will be in this period of time. Do I have a collision? No, move on. ABC, do I have a collision? No, move on, etc., etc. But because we've marked this one as a bullet, what the physics engine will do, and I don't know how many more iterations it gets, but it will get more iterations. So instead of ABC, it may be A, B, C, D, E, F. Maybe it does 6 iterations, like double the iterations. If somebody in the audience knows this answer, they should let me know. But this is sort of like an internal thing where I'd have to see the code and implementation to know for sure what it is. But long story short, what we're doing is every isBullet object is getting more attention from the physics engine, doing more iterations per frame, and which gives us a better chance of having one of those sub-path points actually collide with the body and get us our response and our collision detection. So,
Makes sense.
Go ahead.
Oh, I just said it makes sense.
All right. Good. I'm glad that made sense, because the next step, which we're not going to do, as I said, it's too elaborate for a 10-minute discussion, is the physics engine also gives us a whole bunch of other tweakable parameters, which is we can increase for all bodies how often they get calculated on, how many calculations or passes they get per frame. And we can do that for velocity calculations and some other things. There's a number of tweaks that we can make that make the physics engine more accurate. The drawback of this is the more calculations you do, the more calculations you do. So if you had 100 bodies that were doing 3 calculations per frame, that was 300. But if you amp it up for everybody to be 10 calculations, that's 1,000 calculations per frame. So not so much of a problem, less of a problem for desktop, but a very significant issue if you're adjusting these things on your mobile game, because you can quickly get to the point where your physics calculations are intractable. You are unable to complete them within 16 milliseconds or 33 milliseconds, which is either of your basic frame times for 60 frames per second or 30 frames per second, respectively. So we won't go into that today. That's a very deep topic and a dark hole that nobody really wants to jump into unless they absolutely need to. Instead, let's move on to collision, and we can get that done in the time we have left, and then I will elaborate on next week's topic, which will be more exciting visually and get us much closer to where we want to be for this game. So, what have we done so far? We've created the arrow, we've added the body. I'm going to go ahead and leave the isBullet true. Hopefully there's no typos in my code. I'll just put it in the body definition. I don't really need this because my arrows aren't moving all that fast, so they're calculating just fine. The collisions are occurring, and I got really big fat bodies, so it's clear that these are not going to pass through. Let's put this back up to 10 so I can get grazing hits for this discussion. I keep track of the arrows in a table. This is not part of our discussion today. Last week we talked about, and today we talked about drawing out the steps so you can see what's going on. Let me just get past all this. And let's get to the collision handler. So if you wish to do something about a collision, you need to provide a collision handler. And a collision handler is basically a function, in this case, that takes a reference to the object that's doing the colliding and an event. And the event passes in all kinds of useful information. The time of the collision, perhaps the position of the collision, I'm not sure. I always get these a little confused in my head because I don't use all the parameters. We have 3 types of collision handlers. We've got pre-collision, collision, and post-collision. And they're used respectively for very discrete purposes. But 99% of the time, you're going to be using the traditional collision handler. That's the one you need. Typically, you're going to use the pre-collision handler if you want to do something, as you would imagine, in advance of the collision. In other words, just before the collision occurs, you need to do something with the body. A good example of this is just a sideline here. If you're making a platformer and you want the player body to be able to jump upwards and pass through the bottom of platforms, but when it's coming down, you want it to be able to land on the platforms, you can use the pre-collision listener to see that you're about to have a collision, and then you can say, the body is moving upwards and it's going to collide with the bottom of this object, temporarily disable the collision, let it pass through, and then re-enable that collision, so on the way down, it lands on top of the platform. And that's how we get, it's a little bit more elaborate than that, but that's, in a nutshell, that's how we get one-way platforms in platformer games. But for our usage, we're going to use the traditional collision handler, and the two parts that I really care about are self, which is going to be the arrow, the thing that's doing the colliding, and then other. Other is a field that gets passed in as part of the event, and other is the object that the arrow is hitting. So whereas self is the arrow, other is the enemy, because we're only allowing collisions between enemies and arrows. That's how we've set up our collision matrix.